What we're making are long bed, wide bed, vertical machining centers. The bottom line, they're custom bed machining centers for an affordable price to give shops an option to get into a big machining center to do big parts so they don't have to buy a $1 million bridge mill or something that's just completely out of their budget. We're changing CNC machining with our capabilities and design. So if you need it, give us a call. We can build it and make it suit your needs. Hey, Nick Kennedy, FlexCNC. Hey, today we're doing a time analysis for a customer doing some dynamic machining in a block of aluminum. So what we did, we went and reached out to Kennametal to source a really nice end mill so we could really get our machine times down. And to explain this end mill a little bit, this is a 3/4 inch Kennametal Maxi Met. With this guy, we were able to take a 3/4 inch depth of cut, a 225 thou width of cut, and feed it around 90 inches a minute at 4,000 RPM on the FlexCNC. What we're going to show you is how using this tool versus your traditional 3/4 inch end mill, we're able to take our time from 10 minutes and 30 seconds down to 1 minute and 50 seconds. So using the Delta controller on the FlexCNC and high-speed tools, we're able to take a part like this and whittle it down in about 1 minute and 50 seconds. It's an awesome time analysis. The FlexCNC gives us a ton of machine bed to work with, and we'll be able to show you all those details and how setting up parts like this, we can set them up in stations and literally every minute, 50 seconds, make a part like this, nonstop. using smart programming, great tools. Give us a call, 800-837-2503. Let us do a time analysis for you and show you what we're able to do with that FlexCNC and how we can help you make more money on your next job. Hey, today we're going to show you a pretty cool application, 20-foot long piece of tubing, set it up on the CNC, one op. We're going to go through the top side of the part with the drill in this case, wrap it through and then drill through the bottom. No flipping of the part, just setting up on the machine once, hitting cycle start, super fast. Again, nothing's going to be faster to process a job like this. You can see how long these things are, how heavy they are, how difficult they are going to be to set up on any other machine. What we're going to be running is 1 13/16 inch drill. About a little over 12 inches long because we have to go through both sides of the tube. Again, so we can do this all in one op. We don't have to flip the part. We don't have to do multiple ops. We're going to set up on the bed and do it all in one setup. We're going to hear a little bit of some squawking just because it's such a long drill, but it's the only thing we can use to get it all the way through the part in one setup. So that's it, running the 20-foot long tube. Got 9 holes, takes us about 9 minutes and 25 seconds. So I mean, that's super fast for such a big part, such a big hole, especially to go all the way through. Again, no better machine to run that on other than the FlexCNC G-Series, big gantry. Give us a call, 800-837-2503, and let us do a time analysis for you and show you how you can save a ton of machine time using the FlexCNC big bed gantry.
We got the 2 different Allied drills here today that we'll be testing out. One is the Gen 3, the other one is the Vortex. They're both the same diameter, but different speeds and feeds, going through the same material, going to the same depth.
What's up, everybody? This is Eddie. I'm here with my man Scott from Allied Machine, and we are coming at you live from our beautiful facility right here in Walpock, Ohio. We have another amazing demonstration with you here on our FlexCNC machine. We're super pumped to be able to do this today. But before we get started, remember, hey, give us that subscribe you'll see on this part of the screen. Hit that subscription button, hit that bell so we can keep you in the loop with all the amazing content that we're shooting out. And then give us a huge thumbs up. We'd greatly appreciate it. Also, on this side of the screen, you'll notice that we do have a chat box, and we highly encourage each and every one of you to comment, ask questions, and you never know, you might be lucky enough to have your comment and question lifted up, and we'll answer it here on the screen in real time. Also, anyone who leaves a comment today will be entered in for a chance to win some awesome FlexArm, FlexCNC, and Allied swag. So please make sure you put a comment there, ask a question. We'd love to get you taken care of. So with that being said, we're going to be doing some drilling and some thread milling. My man Scott, man, how are you doing today?
I'm good, Eddie.
Hey, rocking out, man. Well, it's good to have you here from Allied Machine. So tell us a little bit about what you do specifically.
I'm a field sales engineer for Allied, so I go calling customers and help them solve their technical problems. So
right on, right on. Well, it's good to have you. So really, for those who may be vaguely familiar with Allied, what makes you so special in your specific world, man?
well, we offer a broad product range for hole making. We offer drilling, thread milling, reaming, burnishing, and boring. So.
Right on, right on. Well, we love working with you. You think you got some amazing tools, so we appreciate you joining us. So again, let's get to the demo. That's what everybody's here to see. So we're gonna go over here to my man, Aaron. Hey, what are we doing? What's going on? What are we gonna be seeing today?
So we're gonna run some different styles, different sizes, and different pitches of the Allied thread mills. We got different drills from them as well. We got the TA style Gen 2, the Gen 3, we got solid carbide drills. We're gonna run some stuff on some 1018 steel, and then we're gonna run a thread mill on some stainless. So I'll go ahead and let Scott talk about the first one that we're gonna run while I get the program going.
So our first hole we're doing is going to be a 3/8 16 thread. We are running our solid carbide ASC line. We offer that product in 118 to 787 diameter range, 3.5 times, 6 times, and 9 times deep.
So that particular drill, I ran that at 3961 RPM at a feed rate of 35.65 inches per minute. So now what we're gonna do, I'm doing a tool change right now to the thread mill. And Scott, you can go ahead and talk about the style of thread mill that we're gonna use.
So this is a 16 pitch solid carbide thread mill. And we'll be running this on 2 different size holes. On our next demo, it'll be larger.
Now, Scott, I'm curious, so while we're getting this bad boy loaded up, obviously FlexArm, we're known for tapping arms. We're known for making the tapping solutions easy. So I know there's a little bit of a difference between tapping and thread milling. You want to talk about that a little bit?
Well, some of the advantages of thread milling versus tapping, you can control your size of your hole a lot better. With tapping, you have issues with tool breakage, getting stuck in your part. With thread mills, you don't have that issue. So if you have an expensive part you're running, you can avoid scrapping a part. So.
Very good, man. All right. What are we looking at here? Good deal. Making a quick switch. We'll be able to check out this part here. So what are we looking at here?
See if Tiffany can get in on the threads here. We're gonna run all these threads on this same block so you can see them all together once we get them all through here, but there we go. So I'm gonna get this loaded up again, and like Scott mentioned, we're gonna run a 3/4 16 thread.
So that's a big advantage with the thread mill versus a tap. So we're using the same thread mill on this next size hole, which is 3/4 16. So with the tap, you'd have a completely separate tool for this hole, and with the thread mill, we do not. So
yeah, I think it definitely speaks a little bit to the versatility of that specific tool. That's pretty awesome, man.
Yep,
it's very awesome. Now, since we're using the same type of thread mill here, are there any specific properties that you'd like to mention about this that does essentially allow it to do both of these sizings without having to change the tool?
So the pitch of the thread is built into the tool.
Okay.
So it just swings a larger arc for this diameter hole. Now we do offer a much larger diameter, and if you were running all 3/4 16 holes, you would want to run a larger diameter solid carbide thread mill.
Very good.
This is just showing some versatility.
Very much so, very much so.
And our drill in this hole, we're running our Genesis XT, and it's a drill chamfer tool. So it actually drills and chamfers the top of the hole all in one shot.
Well, we got my man Christopher Davidson. Hey, I appreciate you commenting here, asking what's the material. Aaron, do you know what material we're running today, man?
Yeah, right now I've got some 1 inch by 2 1/4 1018 steel. And then, like I said a little bit ago, the last demo that we're going to show for the quarter MP&T is going to be in some 304 stainless.
Great question, Chris. Any more comes up, please let us know. And also, while we're waiting, if you're joining us here on the live stream, feel free to comment where you're joining us from. We'd love to know exactly where everyone is coming from so we know exactly who we're connecting with. So we'd appreciate that. Oh, my man Fred. All right, Fred Freeman. How many holes do you think you can do with that 3/4 16 thread mill? Scott, I think this might be a question for you, my man.
Well, that's always a loaded question, but a good response to that is the advantage of a thread mill. As it does start to wear down, you can offset it to control your hole size. Where with a tap, if you start losing size, you got to start running a new tap. So.
There you go.
Material comes into play, obviously, as far as tool life and things
Sure,
like that.
sure,
So.
absolutely, absolutely. No, Fred's definitely one of our good followers. We appreciate you joining every single time, Fred. You're a stud. All right, let's get this part dried off, see what we got going on here. So correct me if I'm wrong, we're really same thread mill, so we're getting the same type of pitch there, but just two completely different sizes of hole, man. I think that definitely, again, speaks to the versatility of that specific tool, wouldn't you agree?
Yeah, yep.
Sure.
The diameter range is, you have a lot more options versus tapping. So.
Yeah, very good, very good. Well, right on. Well, I know we're probably essentially moving on to that next one. So what do we have rolling next after this first tool?
So the third demo is going to be a half 13 hole. We are actually using a different style of thread mill. This is our T3 line. See if we can zoom in
Get
on
close
that.
in there, yeah. There we go.
So our T3 product line is designed for harder materials. Obviously we're cutting in 1018, so we don't need it, but it is a 3-fluted left-hand cutting. So we actually thread mill from the top and work our way down.
You know, it looks good. So while this specific part is running, we talked a little bit earlier about controlling those thread tolerances. So how do you do that?
So you can do that all in your control by changing your offset and your tool offset.
Okay.
So,
okay. Very good, very good. All right, looks like we just got the drilling done. Now we putting in the thread mill tool.
Yeah.
Very good.
That's another one of Allied's solid carbide drills that we use there is 2764s. And we're doing the tool change right now to that T3 style thread mill.
Oh, well, look at that. Looks like Mr. I'm not even gonna try to reach out. There we go. One. All right. Hello from the UK. Man, all over the world. Allied machine thread mills are amazing. Working all materials. That's the kind of love we're talking about here, man. That's right. Way better than a thumbs up. And Nick Kennedy here says, what's the smallest that you can go on thread milling? Scott, what do you think, man?
Nick's gonna catch me off guard, but we go very small. Yeah, it's like 40 some thou. I should have been better prepared for that.
No, it's no worries. If Nick Kennedy does anything, he catches people off guard, so it's all good. And that's what these questions are for, so we love it. Keep those questions coming, everybody. So what do we got going on, Aaron?
So The previous two demos that we did already with the 3/8 16 and the 3/4 16, you kind of noticed that the cycle time was fairly quick. And that was all based off of the fact that the thread mill that we used was a full fluted thread mill. And like Scott mentioned, this is a 3 fluted thread mill. So how we have to cut this hole is we're actually helixing down into the hole. So cycle time is a little bit longer, but like Scott mentioned, it is for a harder material. It gives you more stability. A full-length
thread mill and hard materials, you would get some deflection, and you may have issues with your hole size. The T3 will make up for that.
Yeah, right on. Let's check to see how this bad boy turned out. Thus far, man, making some quality threads, dude. Quality threads. All right, let's give this a look.
So this hole over here is that half 13 hole that we just did. These two, and this was the 3 fluted T3 style thread mill that we just ran. And then, like you saw before, these are the 2 16 pitch full fluted thread mills that we ran previously. So I'm gonna load this block up again, and we're gonna do a 3/8 NPT.
All right, so with the previous tools that we've used, this is obviously going to be a little bit of a different situation. So what can we expect, or what are some different features about this specific tool, Scott?
So this is back to our solid carbide thread mill line. This is an NPT. We can do the same thing. We're going to run this 3/8, and then our last one we're dropping back down to a 1/4 NPT hole, but in a different material. So.
You know, we're obviously, Scott, displaying a wide range of capability and different types of tools. So what other thread mills does Allied offer that would either be comparable or just similar to what we're looking at now?
So we offer a whole range of indexable product. So if guys want to have a holder but they want to run different pitches, they can just change their insert out.
Okay.
Offers a wide range as far as diameter goes. And another thing to keep in mind with thread mills is the ability to do internal and external threads, or right and left hand threads.
So we got Nick Kennedy again. This guy's consistent. Is depth control easier to hold on thread milling?
Yeah, it's it's all controlled by touching the tool off, and you can put thread mills in. A lot of times your taps, they have a lead to them and things of that nature. The thread mill, it acts more like a end mill cutter. So.
Okay. No, very good, very good. So we got some good stuff going here.
Hey Isaac, real quick, do you still have that the programming website up for Allied?
There we go. Let's get that pulled up and talk a little bit about that.
So I know that could be one of the questions that you would get was how would you program? Like I said, on the T3 style, we had the helix down into the hole, the full fluted. You're going full depth to make that thread. Scott, go ahead and talk about your guys' website here and what you can offer for the programming.
So we offer an online version and a downloadable version that you can put on your PC. I recommend using the download when you can, but our online is always available on your phone, any device you have. So Isaac, if you go ahead and click on the online. So here you basically just pick the product that you're looking at. We can continue on from there, Isaac. And this gives you the ability, you can pick out your material up at the top, drop-down window. You can pick out the actual item number you're using in the next drop-down window. And from there you can continue on, and it will ask you, and so we have a pipe tap picked out right now, so you have options for in that drop-down window as well. and it will give you suggested speeds and feeds and the number of passes. And then once Isaac hits continue again, it will spit out all your G code there for, you can cut that out of this and paste it right into your program, and you're ready to roll.
So I know on the next demo that we're going to show here in just a minute, and then the stainless, I put 5 holes into that part. And the nice thing about that, the programming website from Allied, was it runs at an incremental. So all I had to do was copy and paste into a different hole location, and I'm just running the same cycle. So as far as ease of programming, if you're a little worried about on how to program it, using the website that Allied offers was a huge advantage in that. So I'm going to get this stainless part set up, ready to go, and we'll rock and roll.
So knowing kind of what it is that we're doing, Scott, on this this 5th tool, is there anything you can specifically tell us about it?
Well, with this being stainless, sometimes the material itself is made up different. So it actually is going to pull a little bit, but we don't have any issues cutting it too. So
Very good, man.
we'll be running our we're running a Genesis with our stainless steel geometry in it on this hole.
There we go.
To answer Nick's question earlier, we'd go down to 2 millimeter with our thread mills.
There we go. See, you can't stump you. I'll try. I can't stump you, though. Not the experts, man. Not the experts. This is good. This is good. All right. There we go. Get a little bit of a view of live what's going on. See some of the thread milling action. Or actually, this is the drilling. Okay, yeah, this is the drilling. All right, good deal, good deal. Looks so good. So with that being said, while this is running, I guess I'm kind of curious. You obviously offer a variety of thread mills. Do you have any specific one that's your favorite?
So I think the first thread mills I ever ran were for MPTs, and
Okay.
I think running a thread mill on an MPT hole is just far above better than running a tap, because they pull a lot of power to an MPT does.
Right.
So thread mill is just much easier, much more free cutting.
No, very good, very good.
Drilling the last hole, and then we'll do the tool change over to the thread mill. And once again, it's the quarter MPT is what we're thread milling. We're using the same thread mill that we used in the 3/8 MPT.
So again, showing that variety of hole sizes using the same tool. So
Yeah, absolutely. Just like with our first 2 passes using that same thread mill. Awesome.
Yep.
And we moved it from the 3/8 size to the 3/4. So we're taking this one from 3/8 and then going down the 1/4. So
Right.
that's solid. That's
Yep.
solid, man.
Yep.
Loving the versatility of these tools. Truly, truly. What a great way to be able to display what you can do. Oh, another question. Nick Kennedy, my guy. Now, if I'm in a cut and break a thread mill, assume it's not as critical as breaking a tap. Scott, you want to tackle that one, big guy?
Yeah, absolutely. That's a very true statement. I mean, a lot of times you break a tap in a hole, the tap's still stuck in there, and you either have to burn it out or end mill it out, or you may scrap your whole part. With a thread mill, a lot of times if it breaks off, it's going to drop either through the hole or to the bottom of the hole, and you just got to get the material out of there. So a lot safer, especially if you've got a lot of money invested in your part, and threading is oftentimes one of the last operations. So you break a tap off in something that you put a lot of money in, you know, it can be very costly. So
No, absolutely. A lot of the customers that, call in for the tapping arms specifically, talk about broken taps, things along those
Right.
lines. And it's an issue. It's
Yep.
truly an issue. So being able to solve that is fantastic. I think it's amazing. That's amazing. So no worries here.
I need to change my tool real quick.
No worries. Do we happen to have any pending questions? No worries. Sure, we might get one soon. Good deal.
So another thing with the thread mills, though, it gives you the advantage of producing a left or a right-handed thread using the same tool. So you basically just change the helix that you are programming into the machine is what you do. So.
Very good, man. Well, right on. And while we're finishing processing this, I know we talked a little bit about potentially, your favorite thread mills that you offer, but do you have any other types of tooling that you really feel, is just, everything you have, I'm sure, is a high quality product.
Absolutely.
Absolutely. So, but something you think just stands out above the rest and maybe one of your more popular tools that you offer?
Well, how about I touch on, we went over our Gen 2 and our Genesis and our solid carbide. We offer an indexable line, our Vortex, that's a very new product for us. We have rev and opening drills that are for larger diameters, and our APX drill line that's for deep hole, large diameter drilling. And then a whole array of boring tools with our wall hopper and Criterion offering.
Okay.
So.
No, absolutely. So I guess I'm kind of curious because you see a lot of, we hear about a lot of different tapping operations, so there's a huge comparison when it comes to the thread milling, but are there any specific, maybe really cool applications where you've been able to be a part of that involved some of these thread milling tools just by chance?
Well, once upon a time I actually used an indexable thread mill to put serrations on a part.
Okay.
So it wasn't actually threading, but it's creating serrations on a part. Versus tapping, it just gives you a wide variety of things you can do. So,
yeah, very good here. All right, I got Aaron working on a couple things, doing a part switch out here. And then, so with that, again, I know we've covered a handful of these just general thread milling. We've got, we featured at least 3 here today. So are there any other popular lines of your thread mill that you'd like to discuss? Or what do we have here, actually? Oh, the end part? There we go.
There you go.
All right, well, let's look at this, man. Man, that's pretty. Get this moved here. Look at that. Just the typical quality when you put that FlexCNC paired up with some Allied machine tooling. I love it. I dig it. Look at that.
I was talking about earlier on the stainless how the thread mill wanted to kind of pull the material up a little bit. What we did do after we thread milled it was we did come in and run a chamfer to take that burr off of the top of the hole.
No, it looks great. It looks absolutely great. Thank you so much. Appreciate it. Well, I mean, as far as I know, correct me if I'm wrong, Aaron, but that's really all that we had lined up for today. Is that correct?
Yeah, that's all we had.
Right on. No, seriously, I'm genuinely pleased with kind of how things worked out today. We got to show a lot of the versatility, just as well as the general ability of some of your tools, man. So with that being said,
Fred won the drawing.
Oh, Fred? Oh, my man, Fred. Looks like your consistent love has proven true, man. So you want to show us a little bit more love before we end here in a minute, man? That'd be great. But congratulations. We'll make sure to get in touch with you so you can get some of that FlexCNC and some Allied swag, man. We'll hook you up for sure. So with that, any other general questions, Isaac, we have in the chat? That's what I'm talking about. But most importantly, obviously we're going to be drumming up some interest. People are going to want to learn more about Allied. So how can they do that? How can they figure out and get more information about you?
well, the easiest thing to do is go to www.alliedmachine.com. They'll put you in touch with your local field sales engineer, and we'll be more than happy to help you.
There you go. Good people doing good things. I love it. So, hey, thank you so much for joining us. It was an absolute pleasure. Thank everybody in the comments as well. Seriously, it's been awesome. We love doing these live streams and having experts like yourselves and our good friend and ally joining us. So make sure that you join us on our next live stream demo. We're going to be slinging around this bad boy. Now, can you tell me anything about this thing here?
This is our APX drill. So this is meant for large diameter deep hole drilling. So.
Whew, look at this monster. That thing is massive. So what is this? Is this 2 inches?
I don't know what diameter.
No
that
worries.
is.
All I know is
it
it is a
looks round to it.
monster. Yeah.
Yes.
So nonetheless, it's a beast. We're gonna run it because we're not afraid. That's how we roll, man. We're gonna do it. So with that, it was fantastic having you. Everybody, make sure you hit that subscribe button, hit that bell so we can keep you up the loop on all the amazing videos, and give us what my beautiful daughters would say is a huge thumbs up. I know Scott will. So that being said, again, thank you all. You stay awesome, stay flexing, and we will see you next time.